What's up everyone, Jason Trilly here, and today we're looking at pwnable.kr, which is an online wargame website similar to PicoCTF or overthewire.com. And if you're not familiar with either of those, I do have videos showcasing some of them. And if we scroll down here, it gives us a little blurb on what pwnable.kr is. So it is a wargame website which provides various Pwn challenges regarding system exploitation, which is one area of computer security and computer science. You can argue that when you start looking at low-level things like C and assembly and the stack and registers. The main purpose of this website is to be fun. I don't know why fun is in quotes here, but please consider each of the challenges as a game. However, if you just want to study Pwn related stuff, so system exploitation related stuff, check out these videos down below. And they have 4 videos here about this YouTuber Pwn function. I highly suggest checking out his site as well. His videos are very detailed, and he even has these nice animations and graphics, and his mascot is a penguin. I'm not sure if that's a reference to the Linux penguin, the Linux mascot Tux or whatnot, but I do like his videos. He is a very good YouTuber, a very good educator as well. Scrolling down, it gives a blurb on how to play in the 4 different, categories, the 4 different levels, with toddler being the easiest. So the beginner challenges, more typical exploitations for rookies. They have harder ones and harder and so on and so forth. Disclaimer, skip that for now. And then this is what I wanted to showcase right here. So underneath rules and tips, rule number 3, we do have the go ahead. We do have the authority to post challenges and solutions for the toddler's bottle, which is the easiest introductory level war games, but nothing else. So all the other categories, it's not recommended to post any solutions online because that spoils it and that takes away the fun and the mystery and the allure of you guys solving it yourself. So enough rambling, enough talking out the way. Let's go over here to play. And we see the different challenges, and they all have these different cards, of these like cute bootleg Pokemon kind of creatures. And we scroll down and we see the other categories, Rookiss and Grotesque and whatnot. So a good sizable chunk of challenges to solve. But we're going to get started with Toddler's Bottle, the first one. It has this border around it, these dots, that just showcases, hey, I've already solved it, and I'm just going to walk through my solution today. So we click here, it pops up at this box. Mommy, what is a file descriptor in Linux? And then a big note, try to play this war game by yourself. And if you are absolutely a beginner, you can follow this tutorial link. And then they give us the connection line, secure shell. The username is just file descriptor. This is the host name on port quad 2. So let's grab this, mosey on over to our terminal, and we can slam in that connection line here. Yes, and the password is just guessed. We get a nice banner. Okay, let's do ls tag la to list everything in here. Okay, there's a file descriptor.c, and a flag. We don't have permissions to read that flag file, right? That's owned by this FD Pwn user. Let's run the file descriptor program, FD. It prints out pass argv1, a number. So if you're not familiar, in C and C++ as well, Java, I haven't programmed in Java in a while, but there's different argument vectors. That's what argv stands for, with argument. So it's an array with the 0th index. The first index is the name of the actual program. And then the next index, index 1, is anything you pass in on the command line. So FD, and then we need to give it a number. Let's do leet. Learn about Linux File IO, so input and output. So let's cat out file descriptor.c so we can look at what's going on. It imports some standard library stuff, string.h, just these standard header files. We see the main function with argc being the argument count, so how many arguments are you actually passing to this function. Argv is the vector or the list that contains the different command line arguments. And then nvp is the environment pointer. You don't really see this too much. You typically just see these first two, but it's not wrong or incorrect to also include an optional environment pointer. But we're not messing with the environment variables today. We see if our argument is passed or less than 2, it'll print out that message that we saw earlier. Please enter a number. And if we want to be silly, we can do, I don't know, whatever. And we're still going to get the same result of learn about Linux File IO. And then here we have the actual crux of the program, the actual meat and potatoes. We see this string function ASCII to integer is being cast on whatever we pass in as argument 1. So essentially we give it a number and it's going to subtract OX1234, declares a variable called length, sets that equal to 0, and then it reads from our file descriptor, so what we pass in, into a buffer up here, and then it calls this string comparison function. So what is this doing? So read is going to read from a file descriptor. So we've been saying the word file descriptor a lot, but what actually is a file descriptor? It's essentially a handle in Linux and systems programming that tells the operating system, the program, where am I grabbing this data from? So if I look up file descriptors in Linux, what's a good resource? Wikipedia is fine. And I apologize for any background noise you guys might hear. My upstairs neighbors are moving, so it is pretty loud, right? They're lugging around furniture and whatnot. You see here in Unix and Unix-like computer systems, a file descriptor, or FD for short, is just a process unique identifier or a handle to a file for input and output resources. And it's not limited to just files, right? It can also be sockets for networking or pipes for redirection. And we see the common file descriptors, the ones, I guess, built into the operating system, are 0, 1, 2, and 3, input, output, and error, respectively. So we see here, if I can cap that program out again, it's subtracting OX1234 from our file descriptor, from our user input. And if this is too confusing, let me just grab this program. Let's make a directory in temp. That already exists. Make dir temp. No, it's not a real program. Okay, cd into this directory. There's nothing in here. Let's open up our own file descriptor.c. Paste this in. And let's add some print statements. fd equals this. Okay. Complains that I can't write to home file descriptor.viminfo. We don't have the correct permissions to write to our home directory. That's why I created this directory here in temp. Let's compile this with GCC. And why not? Let's throw all warnings. Oh, I need this to be printf. Okay. Recompile. That's fine. We now have our file descriptor executable. Let's change the permissions on that. And finally, let's execute it. Oh, okay. So whatever, let's pass in this. And we see our output, right? Can I zoom in? Negative 3,332. So it's subtracting OX1234, and it's using negative 3,332 as our file descriptor, and that is not a legit thing. We want it to be ideally 0 for input, because that's where you type in all of your, commands, right? That's where the Linux operating system reads from. So we can look at Python. What is OX1234? It's 4,660. So let's paste that as our argument. And we see the program, and now it just hangs. Why is it hanging? Because it's waiting, it's pausing for this read character, or this read function. It's waiting to read our input from standard input. So we can type in whatever, please sub, and we still get this error message or this like warning message. And that's because right here, we want to enter this password or this phrase, let me win, which will make this if statement true. And then it will execute good job. And then it'll print out cat or print out our flag rather. So let's rerun this. Let me win. Let me win. Good job. And it tries to print out cat, but that's not actually, or it tries to print out our flag, but a flag is not in this directory. So we need to go back to our home directory. That's where the flag is. So now if we execute this 4660, let me win. There we go. It prints out our flag. Mommy, I think I know what a file descriptor is. So you can just grab that and then slam it in here and it'll tell you, good job, you've passed. All right, so I've already solved this, so it prints out you've already solved it. If we want to play around more, we can increment the file descriptor by 1, and we see that because file descriptor 1 is standard output, however, it still pauses and hangs and waits for us to type something in. So let's once again just do let me win, and it still prints it. We can increment this again. Now it's at file descriptor 2 for standard error, and it still hangs and lets us do it. We can keep playing around if we want. All right. So as long as you have it, I guess, as one of the 3 built-in file descriptors, that's how you can get it, the read function, to hang and pause and wait for your input. So there we have it. I know that was a pretty slow, pretty methodical walkthrough. You guys were probably yelling at the computer screen the whole time. Just hurry up, dude. This is simple. But I want this to be approachable for people who maybe this is their first time and maybe using Linux, or first time hearing about file descriptors or different systems programming related topics. So hopefully, I go through and we can knock these out, and maybe they'll be a little bit faster. Maybe they'll be a little less verbose in explanations, but there we have it. That's how I solved it. Pretty simple challenge. I'll knock out these other ones and upload videos as I do. As always, thank you guys for sticking around. Thank you guys for watching. Let me know any questions, comments you guys might have down below. Follow me on social media, Patreon, blah, 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 all that influencer stuff. As always, take it easy and see you guys in the next video.